How many secrets are there in the sunlight? You know what? All substances can generate electricity when exposed to sunlight, but there is no way to collect electricity. Solar panels are also called photovoltaic panels. Photostatic is actually the photovoltaic effect, which belongs to the internal photoelectric effect. There is a semiconductor material called silicon, element photon with 4 electrons at the outermost, sharing electrons with each other to form a stable structure, 4 pairs of covalent bonds. When energy is obtained, the electrons overflow and become free electrons, leaving positively charged holes. With free electrons, silicon can carry an electric current. A boron group element with 3 electrons in the outermost layer. With each boron atom combines with silicon, it creates an additional hole, known as p-type semiconductor, with a greater number of holes than the number of the free electrons. A phosphorus group element with 5 electrons in the outermost layer. When each phosphorus atom combines with silicon, it produces an additional free electron, known as n-type semiconductor, with a great number of free electrons than the number of holes. If you close combine n-type semiconductors and p-type semiconductors, such a phenomenon will occur. There are many n-type electrons and many p-type holes, so when electrons run towards the holes, definitely it will. When a certain amount of electrons move from n-type semiconductor to p-type semiconductor, an electric field force generated will cause the electrons to drift and remain in a stable equilibrium state. On both sides of the junction surface of p-type and n-type semiconductors, a thin layer of ions left. The space charge region formed by the thin layer of ions is called p-n junction, with no carriers inside and is in an insulating state. The p-n junction is also the underlying logic of the diode. When p is connected to the positive electrode and n is connected to the negative electrode, the direction of the electric field is opposite to the direction of the electric field in the p-n junction, thereby upsetting the electric field force. At this time, the circuit in a conductive state and the current can pass smoothly. The reverse direction enhances the p-n electric field force, and the current cannot pass through. This is the unidirectional conductivity of the diode. We let the beam of sunlight to shine on the p-n junction, and the electrons of the covalent band absorb photons, forming energetic photoelectrons. The photoelectrons will transition and form a pair of electrons and holes. Under the action of an internal electric field force in the p-n junction, the electrons and the holes run towards the n end, and the holes run towards the p end. P carries the positive charge, and N carries the negative charge. When the circuit is turned on, a current is formed. This is the photovoltaic principle of solar cells. Currently, the photoelectric conversion efficiency of monocrystalline silicon solar cells is about 15%. The laboratory data also have more than 20%. There are also up to 50% or more solar panels used for space station. A combination of solar panels, controllers, and batteries can collect electrical energy converted from light energy. Lithium batteries are needed for storage. They also have become the best carrier in the new energy industry as present. That's all for today. Hope you like it. If you think our video is helpful, like and subs appreciated. See you next time. Bye.